Hello everyone. We are going to do a project called emotion classification. This project is consists of three members: me, Benjamin, and Sanjeev. Why are we doing this project? Growing a computer domain, the computer does not understand human emotions. In this project, we are making the computer learn about the human emotions and make them to communicate with humans based on their emotions. In this project, we are taking FR 2023 that is explained by Sanjeev.
Hello. This is Sanjeev Venus. This is FER 2013 dataset. FER means facial emotion resolution. Actually, this dataset is created by gathering the results of Google image search of each emotions, and they have made it in a dataset. This dataset consists of totally seven classes. 0 for angry, 1 for disgust, 2 for fear, 3 happy, 4 sad, 5 surprise, 6 neutral. And this dataset consists of totally 30,000 images. In the 20,709 is for training images and 3,589 is for testing images. And we are importing this dataset. First, we upload this dataset into Google Drive, and using GDOM, we are importing the zip file into the code app using GDOM, and we are unzipping the dataset. And this data and the image size is 48 cross 48, and all the images are in grayscale, and the batch size is 32. And we are doing data augmentation because in some classes the data set are not properly segmented. For example, in Angry, the data set has totally 3,000 images, and whereas for Discuss, the data set consists of around only 1,700 images. So make it as same size. We are doing data augmentation, and after the data augmentation, we got around 35,089 images. And as I said before, there are totally seven classes. And we are also plotting the images using random function. We will be plotting some random images from the dataset. And the model will be explained by Benjamin.
The CNN architecture uses its implementation consists of four sets of convolution, pooling and dropout layers, followed by an flattened layer and two fully connected layers. The first convolution layer has 32 filters with a kernel size of 3 into 3 and a ReLU activation function, followed by a second convolution layer with a 64 filters. The max pooling layer with an pooling size of 2 into 2 and a dropout layer with a rate of 0.1. The third convolution layer has 128 filters and a maximum pooling layer with a pooling size of 2 into 2 and a dropout rate with an of 0.1. The fourth and fifth convolution layer has 256 layers and a maximum pooling layer of 2 into 2 and a dropout layer with a rate of 0.1. In the output of the convolution layer as flattened and passed through a fully connected layer with 512 units and a ReLU activation function followed by a dropout layer with a rate of 0.2. The fully connected layer has 7 units with an softmax activation corresponding to an 7 possible emotions. The model is coupled with categorical cross entropy loss and Adam optimizer and trained for 50 epochs with a batch size of 64. Now it will be explained by Sri Harish.
After the model training, the model is saved by model.save, which is a module from Keras, and we are plotting the model graph for checking it is overfitting or not. Successfully, the model doesn't overfit, and we are by using Keras dot modules, we are loading that model. By loading that model, we are finding test tables and predictions. Based on the test tables and prediction and scale and module, we are calculating the accuracy of the model, which is around 78%. And with scale and matrix, we are plotting an confusion matrix, and we are cross checking the model by predicting one of the images from the test tables. And for the cross checking, we are also printing the original labels and the predicting label. Now the conclusion is done by Sanjeev.
Yeah, we can see that this has been we have plot the images we have predicted. Actually, the image is surprise, and we predicted surprise. So this model actually 78% accuracy and this 80% accuracy. So this data, this model can also used for in many places like to understand the emotions. So thank you for giving the opportunity for doing this.
Thank you.